Hi guys. So I'll make this short. And this is C-8. We're on page 22. We're only going to do this page. Okay, so first we'll do an interpretation exercise, and then after that, I'm going to introduce something in your calculator. And then the topic here, recognizing the limit definitions of derivatives and integrals, that topic actually I'm going to cover in class. Okay, but these are still nonetheless things that we need to cover. So, okay, so we'll do an interpretation exercise first. And, okay, so the amount of Arctic sea ice can be modeled by a differentiable function A of t, where A of t is measured in millions of square kilometers, and t is measured in years, I should have said here, is measured in years since January 1st, 2023. Selected values are shown in the table below. Okay, as soon as you hear modeled by a differentiable function, you are dealing with a derivative sequence. Okay, so A prime, and we'll put A double prime in because very often it will be a twice differentiable function, they tell us. And then we'll have to think about the second derivative. Okay, so here we go. Let's think about the units here, because that's going to be an important part of our interpretation. So A of t is measured in millions of square kilometers. So million kilometers squared. And then this one, I don't know what to say. Maybe I'll say km squared over years, and then km squared per year, and then per year. Okay, so interpret A of 0 in the above context. Okay, so A of 0 is, we're interpreting in something from this column here. So, and so this is going to be an interpretation of the amount of Arctic sea ice at t equals 0. So let me just, well, first of all, actually, it could be helpful to get the ball rolling to just write what you're interpreting. Actually, sorry. Oh, and it's right here. Actually, okay, sorry. Let's find it. 12.6 and millions of kilometers squared. Alrighty, now our interpretation, since we're starting here in this derivative sequence, our interpretation is going to go like this. At time t, something equals a certain quantity. And guys, please speed this up. Go ahead of me if you've got this, but I want to piece it together because this is hard sometimes to get used to. So at t equals 0, because this is A of 0, something, Arctic sea ice, equals, okay, and then the certain quantity is 12.6 million kilometers squared. Okay, and then we could tighten it up even a little bit. At t equals 0, they told us the date actually. So on 1/1/23. All right, so let me write it nicely. On January 1st, 2023, the amount of Arctic sea ice is 3.6 million kilometers squared. And now, that's not really how people talk. On January 1st, the amount of Arctic sea ice is, or I should say was that. So you could say, on January 1st, there was this much Arctic sea ice. That's probably more like how people actually talk. All right, so that was part A. Part B, approximate A prime of 20 and interpret your answer in context. Okay, so first we have to find where 20 is, and 20 is right here in the table. So now we're moving over 1. Oh, if you're moving over 1, by the way, that's IROC. That's the derivative. So if you're moving right 1 in the derivative sequence, that's IROC, that's the derivative, that's the slope of the tangent line. They're all the same thing. And this, okay, yeah, so we are going to have to use slope. And this is an interior point, so we're going to have to do AROC on the left and right of that point and then average them. So, all right, A prime of 20 is going to be approximately, I'm going to have to, all right, so it's going to be the average of 2 AROCs because we have 2 that we could choose from, so we'll average them. Alrighty, so I got to do 13.5 minus 12.6. All right, so that's 0.9 over 20. All right, so I did this minus this. I subtracted these, and then I subtracted those. This is the change in y below. And then over here, that would be 0.5 is that difference over 18. Okay. Alrighty, so let's get a decimal. $20 plus divided by 2. Okay, so A prime of 20. All right, so this here is 0.037. And then the units are million kilometers squared per year. All right, guys, so I'm going to really break it down, so please speed up the video or go ahead. But we're going to interpret it in context. So we are interpreting A prime of 20 is approximately this. This is not exact. So we're going to have to use the word approximately, actually, in our explanation. So the way this goes, if you're interpreting A prime, at t equals, okay, in this case, it's 20, something, so I'll say Arctic sea ice. All right, so the amount of Arctic sea ice changes. So how is it changing? Is it increasing? Is it decreasing? This depends on the sign, on whether you get a positive or negative rate of change, approximately. This is positive. So is increasing at an instantaneous rate. Guys, you don't have to say the word instantaneous, that's implied, but you have to say of approximately 0.037 kilometers squared per year. All right, now let me read it. So at t equals 20, the amount of Arctic sea ice is increasing at a rate of approximately 0.037 million kilometers squared per year. All right, that sounds good. And guys, in the interest of time, why don't I let you should write that down. Okay, so write that down in your notes, and let's just move on. So, okay, so introducing Math 8, you're going to love this. So find f prime of 3 for f of x equals this. Use Math 8 to check your solution. So I'll show you Math 8 at the end of this problem, but first we'll do it by hand. All right, guys, we got to take the derivative. And whenever you're doing a derivative, you ask yourself, is this a one move derivative? And guys, the answer is no. The only single move derivatives are if it's already of the form ax to the n and or a sum of terms of that form, or if it's like one of our, formulas. So this is not that. But what I can do is I can distribute the x, and I could do a little algebra move where I distribute the x, and then after that one algebra move, now I see that I could take the derivative of each of those terms. So this is f prime of x is 8x minus 1. Okay, so to get f prime of 3, you're plugging 3 in. Okay, now this is beautiful. So go to your calculator and you're going to hit, and you guys, if you're on a calculator section, you want to use this. Like if doing it by hand is faster than pressing the buttons, then and sometimes it is, then great. But if you're on a calculator section and you like needed f prime of 3, especially if this was complicated, okay, I'm leaving you in suspense. Math 8. All right, now this is Leibniz notation. But the way that it goes is this. It goes d, and then in the bottom you say x. All right, d dx is another way of saying f prime or dy dx. And then in here you put the function, but put the original. So x, like the original form. Okay, and then this bar, guys, this notation, the bar means evaluated at, and then at the end we tell them the x value that we want plugged in. So guys, this is just alternate notation for f prime of 3. And go like that, boom, 23, we got